Uh, Before we come to the main topic of probability application and application of probability distribution, let me give you some basic idea of statistics and the terminology that we generally use, because this is the only unit where you will cover statistics. So at least you must have an idea about uh, different terminology, different definitions and terms that we use. Let me begin with the statistics as such. So what is your understanding of this subject, statistics? Like any other science, statistics is a separate subject as such, which is about data collection, its tabulation, its processing, interpretation, making inferences, storage of data, and reporting of data. And these days, especially, you know that the importance of data in any field, it's not only management as such, but any any field of studies, any field of profession, you will find statistics is very important. We are talking about analytics, we are talking about big data, we are talking about data analyst, and so on. Why? Because data in the form of, information in the form of data and figures, they can easily be processed and interpreted, which we can use this interpretation or the results of data processing can be used for further decision making process. So, statistics as the science which deals with collection of data, its tabulation, its processing. When we say processing, we mean analysis, and then interpretation of the results, making inferences out of those analysis, and how to store and how to report the results is statistics. And then another important point here is that it helps in scientific judgments and decision making. Why? Because decision making or scientific judgment in any business situation, real life situation, for any managerial decision making, it is influenced by the variability and uncertainty of the system. As you all know that, I mean, any no system is so simple where a decision can easily be taken without the help of some decision making process, some information, data which you need to have before you can arrive at some conclusion. And all business like situations, they are full of variations. Variation in what? Variation in the factors which influence the decision making, and a lot of uncertainties are involved because decisions are taken for future and future is not certain. So statistics is important in the sense that with the knowledge of statistics, we can make use of the data and its and the results to take care of the variations in the system, variation in the variables, and uncertainty through, for example, probability estimates. So those uncertainties can be reduced to certain calculated risks with the help of probability estimates. So this is about importance and use of statistics in management, and as I told you, not only in management but all fields of academic interest as well as professional. So statistics is everywhere, and statistics helps in making judgments and decision making by taking care of variability and uncertainty. Now, another very common thing that we generally use, the concept of population and sample in statistics, because as I told you that statistics deals with numbers and figures and data, whatever you call, and this the amount, the quantum of data may be very huge. So whenever we plan to study some system, we either consider the each and every person or individual or object in that system for study, or sometimes we collect a small, we identify a smaller group from the bigger one and then we study. For example, if you want to uh, if if say if you want to find out some feedback from MBA students about about curriculum, about teaching, about any aspect of their stay, this 2 years duration, and then their stay in the department. So one way is that we distribute some questionnaire, some feedback form to all students. Say there are 120 students in four groups of MBA, MBA, MBA IB, MBA Islamic Banking, MBA Hospital Administration. So 120 in the first year and similarly 120 in the final year. So one way is that we collect this information feedback from all 240 students of the department who are currently enrolled. Another way may be that instead of collecting data from all 24 to 240 students, we can select, say for example, 20, 30, 50 students from all the four sessions for all the specialization, and we study their responses. On that basis, we can find out the overall perception or experience of all the groups. The reason being that to study a smaller group is easier, is more manageable as compared to that, because here we are talking about only 240 students versus, say for example, 50 students. But if this larger group is really very large, if the number is in thousand, and this may be either, as I said here, it is students, it may be customers, it may be consumers, it may be companies, it may be company executives, it may be salespeople, it may be, I mean, the operations people, it may be the top management. So whatever group of people, companies, countries, voters we want to study, so that is what we refer to as population in statistics. So this population here does not mean the actual number of people, but it is population here in statistics is defined as that group of individuals, companies, objects, products, whatever is under study. So that is your population. For example, if you write all final year MBA students of FMSR in the session 2019-20. So this is an example of population. But the second one, if a few students of this population who represent all characteristics are selected for some study, then that smaller group which represents the larger group is called sample. And sample should be representative of the population. By representative, we mean that all the characteristics possessed by the population should also be present in the sample. In our case, the two most obvious variables are gender, means male and female, students and groups or specialization, you can say, branch. So there is one group of hospital administration, there is one group of Islamic banking and finance, there is one group of MBA, there is one group of MBA and IB. So if you want to collect data from all of them, and the data are such that the responses may also vary gender wise. Male and female students might have different responses or answers to the same question. So that means gender is one important variable and the specialization is another important variable or the factor. So therefore, if we have 240 students enrolled in the department, 120 in the first year and 120 in the final year, and if you want to collect an information from a smaller group, we want to draw a smaller group out of this. The number we may decide later on, and there is, a separate topic that how to determine that sample size. But say, for example, if we want to select 50 students from this group of 240, so these 50 should have three characteristics. Number one, these 50 should include both first year students as well as second year students. Another representativeness should be that this group of 50 students should have both male students as well as female students. And the third factor of representativeness is that these 50 should have students from each of these four programs. So this is what we mean by representative group. A representative group of the entire group under study is called sample. Then we move to descriptive and inferential statistics. Statistics from analysis point of view is broadly categorized as either descriptive statistics or descriptive analysis and inferential statistics or inferential analysis. Descriptive means when we collect data from a sample. I hope now sample and population is clear by this time. Do you have any question till this? Population sample? Is there any question on this sample and population?
No, sir.
I hope it's clear. So, if we collect data from a sample and analyze the responses, and results are drawn, conclusions are given, we infer something out of it. So that is basically descriptive analysis or part of descriptive stats. There is some disturbance. Please ensure that your microphones are switched off unless you are.
तक बंद है आज लोग सोए हैं कि दोपहर से बंद है जो मैं की आवाज 1 बजे होगी ना आज 1 बजे के बाद से बंद 1 बजे के बाद से आज सब इज्तिमा है इस्लामी तुम्हारे साथ सभी कारण दोपहर तक बंद है
I request all of you that please put your mic off unless you want to ask something or you want to answer some question. So, by descriptive analysis or descriptive statistics, we mean that if we are analyzing data collected from a sample, and we want to describe its characteristics in terms of various factors, then that is descriptive analysis or descriptive statistics. For example, if I ask a question, if my project is such that I want to answer this first question on the screen, what is the average salary of FMSR students who have been placed in 2021. So what we do that we collect data from this 2021 batch who are placed in the corporate world or those who are working on their own. So and then find out their pay packages, and then we can find out either average salary or median salary, whatever. So when we collect data from FMSR students who have just passed out and are placed in the job market, and then we can find out what is the average salary of the FMSR students. What else we can describe about them? Then what is the distribution of, of the places they are working? Means how many out of say 200, how many are working in corporate, how many have started their own business, how many are working in public sector, how many are working in private sector, and how many are in academics, how many are, in different fields. This is an example of descriptive statistic or descriptive analysis, where we are describing some phenomena, some characteristics, characteristics of some group of people, group of companies, group of products, and so on. So that is descriptive analysis. But on the same, data, if you want to know the answer of the second question, is the pay package offered to FMSI students related with their final percentage, means CGPA or percentage, whatever. Is there any relationship between the marks which you have obtained in your MBA, 4 semesters combined, and the pay package offered to you? So if you want to study this type of problem, if you want to answer this, is pay package offered related with final percentage, then this is done using some statistical method. We collect data from a sample. Again, we collect a sample of, say, for example, 50 students who are working in different fields, and then also we collect data on their overall performance or the score in terms of percentage or in terms of CGPA, and then we try to find out whether there is some relationship. Means relationship may be there. What we do, what is called as hypothesis testing. There, what we do that we formulate some hypothesis and then analyze using some statistical method to find out whether, what could be a question, whether pay package is related with your overall performance in MBA, or we can find out the answer to the question that pay package is positively related with the percentage or the marks which you have obtained, or the higher the score, better will be the pay package, and so on, in different forms. So if we need to answer that type of question, then it is to be done not only on the basis of collecting data, analyzing it, and describe the results, but on the basis of some statistical analysis. So that becomes your inferential statistics or inferential analysis. In brief, gaining descriptive statistics is about gaining an insight into the system, into the population, into the group. Then we can analyze in the form of central tendency and dispersion. We may be also interested in pattern of responses data. We can also use graphical representation for describing the characteristics of that group under study. That is all about descriptive statistics. But when we use some probability and various statistical methods to infer or to conclude about the entire population under study, then that is your inferential statistics. Another set of terminology that we use is about the classification of data. Data are broadly classified as on the basis of time of collection and on the basis of nature, which you can see on the screen that primary and secondary data are defined on the basis of time of collection. That means if you collect data first hand, means you are conducting a study and you are collecting data for your study for the first time, then it is your primary data. A simpler example of primary data collection is using a survey, a questionnaire. You develop a questionnaire and collect data from the sample or the population, and then you analyze. So that is primary data. But when you collect data which is already available, means in some magazines, in newspapers, journals, in annual reports from the companies, or any document which is publicly available. So if you are collecting data from that source and you are not collecting data for the first time for your own study, but similar data are available if you want to study something on stock exchange market. So you can take the information, you can take the past record of stock exchange market for the last 5 years, 10 years, which is available, and then either from a company or from any board, then it will be secondary data. You want to study, say, for example, balance sheet of companies, so which are available. So that is secondary data. But when you collect data for your own study, by your own at the first time, then it is called primary data. Then data may be on the basis of nature, it may be discrete or continuous. So discrete data are the data which are measured on a discrete scale. Means if you want to switch over from one category of data to another category or one data point to another point, so there is a gap between the two, there is a jump. For example, when you say male or female, so you have to be either, an individual is either male or female, or if you say whether you are working in public sector or private sector. So public sector, private sector, they are different classifications. So data are discrete. But if you're talking about age, so age can be measured or height can be measured on a continuous scale. Means it can be feet and inches, it can be in weight in kgs. So which may vary from 0 to whatever is the maximum in that category. So we can measure on a continuous scale so that is your continuous data. Now you study in your second semester, there is a course research methodology. So these things will be done in detail there. For example, this should we go for primary or secondary data for any research. So the answer is based on different characteristics. If the secondary data are available and there is no problem of their obsolescence or the unit of measurement or the type of the characteristic data which you are interested in for your research. So if those characteristics are available and you find this data fit for your study, then we should go for secondary data. Otherwise, if the data are not available, then we collect primary data. There are certain merits and demerits of both that we will study in detail. The most common statistics that we use for data analysis are measures of central tendency and measure of dispersion. Measure of central tendency means central tendency is the central position, the middle position of the data. And you know that the commonly used measures for central tendency are mean, median, mode. And there are other also. If you have, weighted average method or geometric progression, arithmetic progression. So based on that, we can have a central measure, central tendency. We can measure central tendency, but the most commonly used are mean, which is mathematical. Median is not always that. Sometimes the qualitative data, which are non-quantitative in nature, their average cannot be calculated like you add all of them and divide by number of data points. So in that way, you can't find mean. So in that case, we use median as a measure of central tendency. That means that is that point on each side of which we have 50% of data. And mode is another measure of central tendency, which is that value which occurs most frequently. A notation that we use for mean of a sample is x bar, and for the population mean we use mu. Dispersion is another commonly used statistics in analysis, and which measures in the form of range, standard deviation, and variance. And notation that we use, the symbolic representation of central tendency and dispersion. Small s is used for standard deviation of a sample, and sigma is used for standard deviation of the population. And this is how we calculate this sample's standard deviation. Standard deviation is the standard dispersion of any data point from its mean. And then we can come to this descriptive and the format of using data. Now, for an example, if 1, 2, 3, 4, 5, 6, 7, these are 14 data points which represent life of 14 car batteries manufactured by a company. So there is a company which is manufacturing car batteries, and they have collected data on the life of their batteries. So they have found that it is 2.2. They have collected data from, say, 14 car batteries. So 2.2 years, 3.4 years, 2.5 years, and its maximum up to 4.7 years. So this is 14. This is this represents car batteries, life of car batteries in years. And this form of data says there are only 14 points here, data points. So when we come across any analysis, so data are huge in number. It's not like 14, 15. It's in hundreds and thousands and so on. So therefore, if we have, say, even 100 data points like this, that is in the raw form or scattered, where it is very difficult to make use of this information. We can't process it. We don't have even an idea about what is the lowest and what is the highest value in this. So even that much we can't do if we have data in this format. What we do, we arrange data, we tabulate data in some form. As I have discussed in the beginning, that it is after collecting data, you need to tabulate or format it in some particular form before we go for its analysis. Because data in a raw form or scattered form may not be of any use. You can't draw any conclusion out of that. You can't make any calculations on that data because they are scattered. There is no system, there is no format. So it is very difficult to find out any meaningful, to extract any meaningful information out of that. Therefore, collection of data which may be done either it is already available in secondary data, as secondary data, or you collect it as primary data, but then we need to tabulate or format it before we analyze and then interpret. So this is the raw form, which is in scattered form. So instead of 14,
अभी तो इंटर्नशिप वाले की तो खैर अभी जरूरत नहीं है, हाँ मैनेजर वाली कर दे, ज्यादा इम्पोर्टेंट है तो कल के लास्ट डेट है अभी हमें.
so it could be not 14 but 140, for example, data point, and it becomes more complicated and difficult to analyze unless you arrange them into some order, you format them, or you tabulate in some particular format. Then the next step is analysis. So the simplest form of its formatting may be the data array. Means you arrange this into either descending form or ascending order. So that is the simplest formatting or tabulation technique for arranging data into either descending form or ascending form, that is called data array. Another better or advanced format of tabulating this data are in the form of frequency distribution. This frequency distribution may be either in discrete or ungrouped form, or it may be in grouped form. So this we will do in the next class. If you have any question till now, please ask, and then we will close this session for today. Yes, would you like to seek any clarification?
No sir, thank you.
No sir.
No, sir. Thank you.